Okay. If I remember correctly, this is where we're about to I think we just finished talking about rounding off, right?
Yeah.
Okay, so the next thing we're going to talk about is how do we deal with sig figs in calculations? Who just walked in? What's your name?
Tony?
Last name?
Keller?
Okay. Okay, so yes, so we're going to talk about how do we deal with significant figures when we're doing calculations. And this is going to utilize some of the things that we learned in terms of the difference between measured numbers and exact numbers. That's important also, as you're going to see. You're also going to see how rounding off works when it comes to doing certain mathematical operations. So the first thing we're going to say here is that whenever you're doing any calculations, the result of the calculation cannot be more precise than the least precise measurement that is involved in the calculation. All right. So what we're going to look at is how do we do or deal with rounding off when it comes to multiplication and division, and then later on we're going to see how we deal with this when it comes to addition and subtraction. So let's talk about multiplication and division. So when you're multiplying or dividing numbers, the answer must contain the same number of significant figures as in a measurement that is involved in a calculation that has the least number of significant figures. All right? So basically what we're saying here is that if you're doing any multiplication and or division, your final answer must be rounded off to the lowest number of significant digits of the numbers involved in the operation. So let's look at this example. Let's say these represent two measured values, 190.6 multiplied by 2.3. So you punch a number into the calculator, press the equal sign, and this is what, and this is what you get, 438.38, right? Now that will not be the final answer because, as I said before, when you're multiplying and or dividing, you have to round your answer off to the lowest number of sig figs. So you have to look at these two numbers here and identify the number of significant digits represented here. So here we have 4 significant digits, and here we have 2 significant digits, right? So therefore what that means is that we have to round off this answer to the lowest number of significant digits, which should be 2. So this has 4, as I said before. This has 2, all right? So when you're rounding off, you have to round off your answer here to 2 significant digits, right? Because this has a lower number of significant digits involved. So therefore, the 438.38 will be rounded off to 440, or if you prefer to express it in scientific notation, would be 4.4 times 10 to the 2. And that's it. All right? So that's what you do when you're multiplying, and that's also what you do if you're dividing, right? And also, if you're doing a combination of multiplying and dividing, you do the same thing. You round off your answer to the lowest number of significant digits. All right. Any questions about this? Any questions? Any questions? Okay. So that's multiplication and division. What about addition and subtraction? Well, the rules are a bit different. Again, what I said earlier applies. The final answer must be expressed to the least precise measurement involved in the calculation. In this case here, this kind of sound wordy. The result that you're going to get. Somebody joined us online. Anyway, the result that you're going to get must be rounded off to the highest place, last significant digits. I'm going to make it simple for you. Basically, you round off to the lowest number of decimal places. All right? And here's an example. So let's say, again, these represent measured numbers, and you add them up, right? Put them in a calculator, press equal, and this is what you get, 306.37. Well, in this particular case, you have to round off your answer to the lowest number of decimal places, right? So you have to examine each of these questions and see how many decimal places are expressed. So here we have 2 decimal places, here we have 0 decimal places, and here we have 1 decimal place. So that means that this answer here must be rounded off to 0 decimal places, all right? So therefore, that's the answer. Well, that's not the answer. That's the answer, 306, right? Which would be the answer rounded off to 0 decimal places, okay? So that's the difference between multiplication and division and addition and subtraction in terms of rounding off, right? If you're multiplying and or dividing numbers, you round off according to the lowest number of decimal places. But if you're adding and or subtracting numbers, you round off your answer, to the lowest number of decimal places, all right? So let's see here. What do I have next? Oh, what if you have a combination of addition, well, in this case, subtraction and then division? How do we deal with that? Because, of course, the rules for rounding off when it comes to subtraction is different when it comes to rounding off for division, right? Now, if you were to put all these numbers in the calculator and then press equal, you're going to get this, right? So the question now becomes, how do we round off appropriately? Okay, so what we'd have to do in this case is that we have to do the subtraction first, right? And when you do the subtraction first, then you round off your answer to the lowest number of decimal places, because that's a rule for rounding off when you're subtracting, right? So 1.039 minus 1.020, and when you do your result, you're going to get 0.019. Now, this has 3 decimal places, this has 3 decimal places, this has 3 decimal places. So therefore, you don't need to do anything extra because this is rounded off to the lowest number of decimal places involved. All right? So that takes care of the numerator part of this fraction right here. So now you're going to put 0.019 divided by 1.039, right? So that's what you're going to do. Now, what you're going to do now here at this stage is divide. And the rules for division is you round off to the lowest number of significant figures, right? So here we have 2 significant figures as the numerator. Down here we have 4 significant figures as the denominator, which means that whatever you get here when you put the numbers in the calculator and press equal, you have to round this off to 2 significant figures, because remember, you have to round off to the lowest number of significant figures. So the final answer is going to be, you drop all these digits here, and you're going to end up with 0.018 as your final result. All right? And that's it. That's basically how that is done. All right? All right? Any questions? Any questions? No questions? Okay. Oh. Did I give you guys assignment 1? No? Shoot. Okay. I should have printed that. Let me just check something here. Okay. All right, what I'm going to do is I'm going to publish assignment 1 for you to do. Let me just check something here. Okay, so assignment 1 is pretty easy. I'm going to make sure it's published, and then I'm going to set the deadline date for that. In the meantime, let me give you or get you started on assignment number 2. Okay, so so based on what we have covered in chapter 2 so far, you should be able to do questions 1 through 4. So let me help you out with a couple of these. And so let me go here. Okay, so in the case of question number 1, they're asking for you to convert the following numbers into scientific notation, right? So if you remember, to get from the standard way of expressing numbers to scientific notation, you have to move the decimal point, depending on the number, either to the left or right, such that the decimal point is right next to the first non-zero digit, right? And then you multiply by whatever you get as a result of that, you multiply by 10 to the number of places that the decimal point jumps. If it goes to the left, then the exponent to which 10 is raised to would be positive. If it moves to the right, then it's going to be negative. Okay, so in the case of the first one, the decimal point, even though it's not expressly shown, but it's understood to be here, right? So you'd have to move the decimal point 1, 2, 3 spaces to get the coefficient, which is 3.4, and then you multiply by 10 to the 3, and that's it, right? So the answer would be 3.4 times 10 to the 3. In the case of B, the decimal point is here. Now you have to move it to the right. 1, 2, 3, 4, 5. So that will be 2.3 multiplied by 10 to the minus 5. All right? So remember, if you have to move the decimal point to the left, then the exponent, right, the number to which 10 is raised to, will be positive. But if you have to move it to the right, then the exponent is going to be negative. All right? Okay, so let's see if you can do C without my help. What would be the answer for C? Yes, ma'am.
1.01 times 10 to the 5th power.
10 to the, 10 to the 5. Yep, that's correct. Very good. What about D? Oh, yes, ma'am.
Would you be able to do it like 1.0 times 10, or do you have to do 1.01?
You have to do 1.01. I'll explain why later on. Okay. What about D? What about D?
0 times 10 to the negative 2.
1.0 times 10 to the minus 2. Very good. What about E?
And 4.501 times 10 to the first.
10 to the what?
To the 1.
Okay. I agree with that. Okay, what about F?
One point zero times 10 to the 6.
Okay, so in this case, let me just say that the answer is actually 1 times 10 to the 6. Now, let me explain at this juncture why I do that. Basically, as you go from one to the other, if you're going from the standard to the scientific notation or vice versa, the number of significant digits should not change. All right? Now, when it comes to scientific number expressions, you only look at the coefficient to determine the number of sig figs. Okay? So, for example, which one was it? This one right here, right? This had 2 sig figs. Because according to the rules, this 0 here would be significant, right? So that means you have to include that 0 when you're writing down the number in scientific notation, right? And now, who was it that mentioned, was it you just gave the last one? Right. In this case here, you said 1.0 times 10 to the 6. The problem with that is that this is 2 sig figs. You see what I'm saying? While this is 1 sig fig. So that means you don't need a 0 here in order to get the correct number of sig figs in the scientific notation. Okay. G. Who would like to tell me what the answer for G is? Oh, somebody's saying something in the chat. Okay, please forgive me for not paying attention to the chat. You guys out there in Zoom. Let me see. Oh, somebody was answering. Oh, somebody's answering the current one that we're doing. Right, you're right, actually. That's Alex Fraser. The answer is 6.71 times 10. Oops. The answer is 6.71 times 10 to the minus 3. Okay, what about G?
Already in scientific notation, right?
I'm sorry?
Already in scientific notation.
No, it's not already in scientific notation. Now, admittedly, the coefficient will not change.
Is it 4.50 times 10 to the 0?
Exactly, 10 to the 0. And somebody's saying something in the chat again. Okay, so that's not right, Mr. I'm sorry, I don't want to misgender you. Alex Fraser, the answer is 4.50 times 10 to the 0, not 10 to the 1. All right, 10 to the 0, anything raised to the 0 is 1, right? So that's why that doesn't change. Okay, so if you understand what we have just done, then that means that you should now be able to do the second part of number 1. Because in the case of the second part of number 1, it's the reverse. Whoops, let me clear this here first. It's the reverse. In other words, you're given a number in scientific notation, and you're asked to write it in the standard notation. So I'm going to leave you guys to do that. If you have any questions, that's what I'm here for. But I want you to do these on your own. In the meantime, let me publish assignment number 1 for you guys. Well, let me unpublish these first. Okay, so let me do this. And publish this. And then do.
Excuse me, Professor,
Yes, sir.
you want to do part two?
You guys are finished with the second part of part one? All right, give me a minute here. Let me just set this up here and then we can proceed.
Yes, sir.
Okay, what I'm doing is setting up the canvas for your submission of your first assignment. So it is going to be due tomorrow. It's a very simple exercise. So you guys should be able to okay, what's going on here? Hold on. What in the world?
It's because the time is 12.
Oh, the time. Yeah, okay.
The one below it.
Yeah, I think it's because your due date and until date are at the exact same time, and it considers that to be before. And so you have to make the until date like the next day at 12.
But I want to make this available to you from today.
No,
Well, yeah, the
until
available
date.
time is fine, it's the until date. Like, if you change it to May 20 at 12 AM, I think that'll
need to
fix
change
it.
it to 11:59 PM.
Oh,
Oh, you have.
that's it, yeah,
That's, I didn't even notice that.
yeah. Thanks. Oh, I'm just gonna manually. Oh, they give you options, so, okay, that solved that problem. All right, so it's due tomorrow, 11:59. All right? Okay, so, where's my copy? So now, let's see. Oh, you know what? Let me bring it up here on the screen. Okay, so the next question, number 2, it says determine the number of significant figures in each of the following. So this question is testing your understanding of the rules that we covered for significant figures, right? And just to remind you, most of the rules have to do with zeros in particular situations, right? So for example, zeros at the end of a number where there's a decimal point, those zeros are significant. If there's no decimal point, then those zeros are not significant. What's the other one? Sandwich zeros are significant, right? Zeros that are sandwiched between non-zero digits. Any zero that comes before the first non-zero digit will not be significant. And I think the other rule is that all digits from 1 to 9, all non-zero digits are significant. All right, so those are the rules. So with that said, in number 2A, how many significant digits are represented in this number right here?
3.
3, exactly. What about B?
3.
3 again. Remember, when it comes to numbers expressed in scientific notation, we only pay attention to the coefficient to determine the number of sig figs. Okay, what about C? 6 is indeed correct. And what about D? 1? No. 4. Right? All the digits are significant, including the 0 here, which is sandwiched between 2 non-zero digits. All right? Okay. Any questions about any of these? Any questions? Any questions? Nope. Okay, now this one is testing what we just, let me clear this first. The next one is testing what we just learned in terms of mathematical operations and how we round off appropriately, right? So let me remind you, if you're adding and or subtracting, you round off your answer to the lowest number of decimal places, right? If you're multiplying and or dividing, you round off your answer to the lowest number of significant figures. All right, so with that said, first thing we need to do is add these numbers up. So 1.25 plus 6.2, and then we minus 8.01, and then plus 0.899. And then I got on my calculator display 0.339 meters. So to what extent do we need to round this off to? 1 decimal place. And why is that so? That's because of the 6.2. So that means that the answer here, the final answer is going to be 0.3 meters. All right? Because remember, if you're adding and or subtracting, you round off to the lowest number of decimal places. Any questions about this one? Any questions? Any questions? Okay, the next one, now in this case, it's a combination of 2 different types of operations where the rules are different, right? Because you have the addition here in the denominator, and then you're going to divide this result by, or this number by the result of that addition. So what you typically do is work out what's within the parentheses first, right? So it is going to be 23.5 plus 10. Now I got down here, I got 33.5. But the question is, to what extent do we need to round off that part of it? I'm sorry? 0 decimal places, which means that this is rounded off to what? 34. All right? Not 33, because you have a 5 here. If the number to be dropped is 5 or greater, you drop it and then you increase the remaining 1 by 1, right? Okay, so now we're going to divide the 78.860 by 34, right? So let's do that. 78.8680 divided by 34. Okay, I got a long string of numbers. So my question to you is, to what extent do we round this off to? What's the rule for dividing?
Around to the same number of significant figures.
The lowest number of sig figs. Right, okay. So how many sig figs are we dealing with here? 2. How many we're dealing with here? More than 2, right? So therefore, we have to round off the answer to 2 sig figs. And according to my calculation, I got 2.3. And also, very important, you cannot forget the units. You have grams here and you have mils in the denominator. So the answer will be expressed to grams per mils in terms of unit. And that's the answer. All right? Any questions about this one? Any questions? Okay, continuing. Clear this here. Scroll down. Okay, so for number 4, what they're asking for you to do is to round off each of these to 3 significant figures. All right? So in each case, you have to round off to 3 significant figures. So what would be the answer, in your opinion, for A?
135.
135 is indeed correct. I would agree with that. 135 meters, don't forget the units. Okay, what about B?
80.0.
80.0, it would be correct. Grams. What about C?
6 milliliters.
I'm sorry?
1,260 milliliters.
1,260 milliliters. And then what about D? 1.20 times 10 to the minus 5 millimeters. And that's it. All right? Any questions about this? Any questions? Okay. Let me clear this. Scroll down. Oops, let me clear this also. Clear the writings. Okay, scrolling down. Okay, so we can't do that yet. All right, so let me go back to the PowerPoint. So let's talk about the metric system, which is a system that is used by scientists all over the world to conduct, to carry out their measurements of pretty much anything, right? So also known as the System International, right? It's a decimal system of units, and it's more convenient than the non-metric, going from pounds to ounces and all that, because basically in the metric system, to go from smaller units to higher units is by a factor of 10 stepwise, right? So it's built around standard units. So there are some standard units for different types of measurements. And then we use, as I said before, powers of 10 to get larger or smaller. So these are the different quantities and the corresponding units and the abbreviation for these units. And at this level, we will only be concerned with the first 5. We won't be concerned with electric current, and we won't be concerned with luminal intensity. So we'll be concerned with length, mass, temperature, time, and amount of substance. Those are the measurements and the associated units that we will be concerned with, all right? Okay, so as I said before, there's some, you can get from smaller to larger and vice versa by using the appropriate prefixes, right? Now, as far as I'm concerned, you don't need to memorize the prefixes because I will provide that for you in the tables, for your test and so on, all right? So actually, this is a part of the tables, what you're looking at here. These are the prefixes to convert from the base unit to larger units. So just to highlight 1 or 2 examples, mega is the same thing as 1 million, 10 to the 6, right? Kilo is 1,000, 10 to the 3, and so on and so forth. And then you have the smaller prefixes, which reduces the unit, the base unit to smaller units. And just to again highlight one or two examples, nano means 10 to the minus 9, centi means 10 to the minus 2, and so on and so forth. All right? Okay, let me quickly go through the different types of measurements and the corresponding metric units. So the first one we're going to talk about is the measurement of length, right? So the definition of the unit of length, which is a meter unit, is based on the behavior of light, actually the speed of light. Basically, what the definition is that it is a distance that light will travel in a vacuum during 1 over almost 3 millionths of a second, all right? So that's basically where we get the unit of length from, based on the speed of light, all right? And when you look at the relationship between the meter unit and the inch unit, that is the relationship. 1 meter is equal to 39.37 inches. In other words, a meter is a little longer than a yard. And then you can have the larger and smaller units of length based on the use of the prefixes. So as we saw earlier, kilo, that prefix means 1,000, right? So 1 kilometer is equal to 1,000 meters, all right? Or if I were to look at millimeters, right? Milli means 1 over 1,000 or 0.001, right? So therefore 1 millimeter will be the same thing as 1,000th of a meter, or you can express it as 10 to the minus 3 meters, and so on and so forth. So that's basically how you establish the relationship between the base unit, which is a meter unit, and the larger or smaller ones as determined by the prefixes. Okay, so we can engage in some problem-solving exercises where we convert from one unit to the next. And the method by which we do that is what is oftentimes called dimensional analysis, right? So this is what is used to convert from one unit to another, right? And basically what you see here is what it's all about. You start off with a value expressed in one particular unit, you multiply it by the appropriate, what we call conversion factor, and then when you do that multiplication, you're going to end up with the answer, which would be the same in terms of equivalence to what you started off with before, but expressed in a different unit, all right? So the basic steps involved, and this is something that you would have to do when you're given a problem, like in a test and so on. You're going to read the problem carefully, and you're going to identify what is known or what is given to you in the question and what the question is asking for, right? So a lot of these questions, when it comes to conversion, they will give you the original number, right? And then you're supposed to determine to what unit you're going to convert it to, all right? And then you're going to determine all the different conversion factors and the units. Units are very important, all right? So this says in step number 2, you're going to determine, basically going to determine the unit relationship. Again, I don't expect you to memorize all these different relationships because again, as I said before, I'll provide the handout, the tables, and the relationships could be between 2 metric units. It could be between a metric unit and a non-metric unit, or it could be between 2 non-metric units. It all depends on what the question is asking for. Okay, so as I said before, you need to refer to the tables if you must. And then you're going to set up your problem in a neat, organized, and logical fashion. And the way you're going to set it up is that you're going to ensure that the units you want to get rid of will cancel out, and the unit that will remain is what you're working towards, all right? So let me see here. And then you do your mathematical operations, which, when it comes to conversion, it's usually multiplication, even though there is at least one exception where it's an addition operation, but we'll get into that later on. Okay, very important, and I'm a stickler for this. Make sure that your answer is rounded off to the correct number of sig figs. All right, so again, you have to remember the rules for multiplication and division and all that good stuff. And then check to make sure that your answer is reasonable. Okay, so let's talk about length conversion. This is a relatively simple example. This question is asking for Well, it gives you the length originally, and it's asking in meters, and it's asking for the answer in millimeters, right? So the way you go about doing this is that, hold on, let me see here. Well, firstly, as I said before, you're going from the initial unit, which in this case would be the meters, and then you're going to multiply by a conversion factor to get it to the unit that you're trying to work towards, which in this case would be the millimeters. So this is basically showing you how the setup is, meter unit multiplied by the conversion factor to give you the units in millimeters. So the question is, what would be the conversion factor? And the conversion factor must be such that it cancels out the meters unit and introduce the millimeter unit, all right? So in this particular case, the conversion factor will take the form of a fraction, right? Where you're going to have the millimeter unit above here, you're going to have the meter unit down here, so that the meter units will cancel out and you'll be left with the millimeter unit, right? Now, what's the relationship between the meter unit and the millimeter unit? It's given right here. 1 meter is equal to 1,000 millimeters, right? So basically, this is going to be how you're going to set it up. Well, there are two possible conversion factors, but one of them is what you're going to use in answer to this question, because you could have 1,000 millimeter above and 1 meter below, or vice versa. This is the one that you're going to use, all right? And this is the answer. I was recording a video, so I'm just going to show you what I scribbled down here. So basically, you start off with what you're given, the 2.5 meters, right? And then you multiply by the appropriate conversion factor, which in this case would be 1,000 millimeters above and 1 meter below. The reason why I set it up this way, as I said before, is that you want to get rid of the meter unit here and here, and you're going to have remaining the millimeter unit, which is what you want, all right? So therefore, when you multiply the 2.5 by 1,000, you're going to get 25,000 millimeters, or if you prefer, you can express it as a scientific notation, 2.5 times 10 to the 3 millimeters, right? Now, one more thing that I need to mention before we leave this example. I talked about rounding off appropriately, right? Remember I said that there are two types of numbers that you're going to deal with, right? One would be the measured numbers, which has a finite number of significant digits, and then the other would be exact numbers, which has an infinite number of significant digits, right? And there are two types of exact numbers, one that you obtain by counting and the other by definition, right? Now, the reason why I'm mentioning that is because you have to take that into account when it comes to these problems, right? Obviously, the 2.5 meters here, that would be a measured number, right? But this relationship here, the meter unit conversion to 1,000 millimeter, right? That would be an exact relationship. So that's the reason why I have exact right here, right? So that means the 1 and 1,000 will have an infinite number of significant digits, right? So what does that mean in terms of your final answer? Well, if you're multiplying 2.5, which has 2 significant digits, and 1,000 over 1, which has an infinite number of significant digits, that means that your final answer must be rounded off to 2 significant digits, right? And that's why I have 25,000 here. That's 2 sig figs, or as I said before, you can express it in scientific notation, which would be 2.5 times 10 to the 3. And that's basically how that is done, all right? Any questions about this? Any questions about this example? Any questions? Okay. So this is just showing you the relationship between the inch unit and the centimeter unit. So basically, there is the obvious relationship between, the metric units for a particular type of measurement. So for example, we just saw the relationship between millimeters and meters, right? That's a given. 1,000 millimeters equal to 1 meter. And then on the other side, in terms of the non-metric units, you have the relationships. Now, these are not as straightforward because I'm quite sure you guys are familiar with, for example, 12 inches equal to 1 foot, 16 ounces equal to 1 pound, right? That's a bit more inconvenient. And that's the reason why scientists use the metric system. And then you have the relationship between the metric and non-metric system, right? And this is one example, the relationship between the inch unit and the centimeter unit. And as you can see here, 1 inch is equal to 2.54 centimeters. And that is by definition, right? That's a defined relationship between the inch unit and the centimeter unit. So basically, we're going to use that information to answer this question. The question says convert 16.0 inches to centimeters. And this is basically how you go about it. So first thing, of course, that you need to establish is the relationship between the inch unit and the centimeter unit, which is shown up here. And then what we do now is start off with the 16.0 inches, which is this, and we multiply by the conversion factor, which relates these two. And the way we set it up, because we want to get rid of the inch unit here, we put the 1 inch down here as the denominator. And then up top as the numerator, we put the 2.54, right? Centimeters. And therefore, what we do next is cancel out the inch unit, put the numbers in the calculator, and this is what I got on my calculator display, 40.64 centimeters. Now, what we have to do in this case is round off appropriately, right? Because as you can see here, this is expressed to 4 significant digits, right? Here we have 3 sig figs. This is an exact relationship, so this has an infinite number of sig figs, which means that we have to round off the 40.64 to 3 sig figs, right? So therefore, the final answer is going to be 40.6 centimeters, and that's how that is done. All right? Any questions about this example? Any questions? No? Okay. Now, the ones that we have just looked at, they're relatively easy because you basically use one conversion factor to go from what the question has given you to what the question is asking for. But in some cases, the relationship between the final unit and the initial unit is not immediately obvious, right? So an example of this would be this question. They gave you 3.7 times 10 to the 3 centimeters, and they're asking for you to convert to micrometers, right? So basically, you have to find some way to go from the centimeter unit to the micrometer unit. Now we know that 100 centimeters is equal to 1 meter, right? And we also know that 1 million micrometer, and this is a typo, well, not typo, but a bit of an error. This should be micrometers, right? We know that 1 million micrometer is equal to 1 meter, all right? So basically, what we have to do is a series of 2 conversion factors. First, we start off with our centimeter value, right? And then we convert it to meters, and then we convert that meter to micrometer. And this is basically how I laid it out right here. We start off with the 3.7 times 10 to the 3 centimeters, and we accomplish the first step where we go from centimeters to meters. And this is how we do it. This is the conversion factor that we use. 1 meter over 100 centimeter. The centimeter units will cancel out here and here. So up to this point, you'd have converted to meters. But we're not done yet because we have to do the next step. The next step is where we convert from meters to micrometers. And this is the conversion factor that is used to achieve that. 1 million micrometer over 1 meter. This meter unit will cancel out with that meter unit. So the final unit remaining would be the micrometer unit, right? So once we establish that, all we have to do is punch the numbers in. And I got as my answer 3.7 times 10 to the 8 micrometers. And again, you have to round off appropriately. We have 2 sig figs here. These are both by definition, so those have an infinite number of sig figs. So therefore, the answer has to be rounded off to 2 significant figures. And that's it. And there are some cases where you might need more than 2 conversion factors. You might need 3, 4. It all depends on, it all depends on what you're given and what the question is asking for. All right? Okay, any question about this one? Any questions? Any questions? Any questions? Okay, so let me see what's next. Oh. Okay, let's talk about some other types of measurements, mass and volume. Okay, so when it comes to the mass, by definition, the mass is basically a measure of how much material is in an object, all right? People tend to use the term mass and weight as if they mean the same thing in everyday language. But technically speaking, they're two different things, right? The mass is the amount of materials that is present in an object, and the weight is basically the force of gravity on that object, right? And the reason why people tend to use the two terms interchangeably is because one affects the other directly, right? The greater the amount of material, the greater will be the weight, all right? But the weight will be different if you take that same object to the moon. Same mass, but the weight is going to be different because the gravitational pull on the moon, on that object, would be less compared to Earth, right? So I hope that explains and makes you understand the difference between mass and weight, all right? So the standard unit of mass is based on this particular platinum iridium cylinder that is kept in a vault in France, right? So that is the kilogram standard that's there. And what this is showing you is the relationship between the kilogram unit and the pound unit. So 1 kilogram is equal to 2.205 pounds, all right? And again, you can get larger or smaller units of the of mass, again, using grams as a base unit. So for example, 1 milligram is the same thing as 1,000th of a gram, or 0.001 grams, or 10 to the minus 3 grams. And then you can have smaller units or larger units, like 1 kilogram is 1,000 grams, all right? And in terms of conversion, going from one unit to the other in grams, it's the same idea as we discussed earlier with length. So for example, you're given this problem, 45 decigram, you're converting it to grams, right? So the first thing you need to establish is the relationship between the decigram unit and the gram unit. 10 decigram is equal to 1 gram. So this is how you set it up. You start off with the 45 decigram, and then you multiply it by 1 gram above as the numerator, 10 decigram below as the denominator. The decigram units will cancel out, so the gram unit will remain, and therefore the answer will be 4.5 grams. And that's how you do that conversion, all right? Now, in this particular case, let me see what's happening here. You're converting this mass to ounces, all right? And in this particular case, you'd have to use the tables, again, that I've provided for you, because the tables gives you relationships. For example, the relationship between the ounce unit and the gram unit. That's where I got these numbers from. 16 ounces is equal to 453.99 grams, right? That's the relationship between the ounce unit and the gram unit. So in this case, we're converting from grams to ounce. So that's 1.67 times 10 to the minus 24 grams. And multiplying by this conversion factor, the gram units will cancel out, and then you do the number crunching, and you'll notice that in this particular case, you have 4 sig figs here. So the final answer is written to 4 sig figs in this case. So that's basically how that is done. All right. The next unit or the next type of measurement is volume. Volume, by definition, is the amount of space occupied by an object. And the standard unit of volume, according to the SI system, is the meter cube. But there are some other units used as well, like liters and milliliters. In fact, the relationship, do I have it here? No, I don't. Okay. The relationship between the milliliter and the centimeter cube unit is 1 milliliter is equal to 1 centimeter cube. All right. Now, the thing is that milli means 1,000th. So if I were to try to find out what, well, let me just write this down. So because milli means 1,000, that means that 1,000 mils is equal to 1 liter. Now, if I were to multiply this by 1,000, right, that would be equal to 1,000 centimeters cubed, right? Now, here's the thing. 1 decimeter is equal to 10 centimeters, right? So if I were to cube this to give you 1,000 centimeters cubed, that would be equal to 1 decimeter cube. So 1,000 centimeter cube would be equal to 1,000, I'm sorry, 1 decimeter cube. Yeah. One decimeter cube. All right? So, I'm just showing you some relationships between different common units that are used in measuring volumes. All right? Okay. There's some instruments that we use to measure volumes, and the type of instrument that you use is dependent on, pretty much the type of experiment you're running, right? So here are just some examples. You have the graduated cylinder to the extreme left. They come in different sizes. The smallest one I've seen is 5 mils, and then they can go up to, I think the largest one I've seen is 2 liters, all right? So this one here is a 100 mil graduated cylinder. And then we have this flask here. It's called a volumetric flask. These are made for more accurate measurements of one particular volume, right? Again, they come in different sizes. I think the smallest one I've seen is 50 mils, and the largest one is 2 liters, I think. And what they all have in common is a mark that is etched on the stem right here, right? So basically, if you add liquid up to that point, then that represents a particular volume. In this case, it's a 100 mil, right? And these are made very accurately, right? So pretty much you can say that the volume is, for the most part, 100.00, if I'm not mistaken, mils, all right? So that's the volumetric flask. And then you have what is called a burette. And basically, this is a bit different from the other two in that we use it to measure the amount of liquid that is dispensed from it. So let me just explain what this is all about. It's basically a cylindrical piece of glassware where you have a stopcock right here at the end. And basically, if you have your liquid inside here, you can basically open this up and the liquid will drain through here. And you should have something to receive the liquid like a beaker or a flask underneath it, right? So the way this works, let's say you have about 15 mils of the liquid. Well, actually, that's incorrect. Okay, let me put it this way. If the meniscus is at the 15 mil mark right here, that does not mean you have 15 mils of the liquid in it, right? Because if you look at the graduation mark, you see that there's a region right here which has no graduation mark, right? So, and that's a very important point to make. Students, especially in my labs, Chem 1 labs, they tend to make that mistake when they meet this instrument for the first time. They assume that because the mark is 15, that represents 15 mils of liquids in it. The way we use this is that we record the initial reading here, and then we put something on here, like I said before, like a flask, and then we open up the stopcock and we drain the liquid, and let's say we want to collect 5 mils of liquid here. We drain the liquid from 15 to 20, and therefore you know that you collect 5 mils of the liquid underneath, right? So therefore the burette is not designed to measure the amount of liquid that is in it. It is designed to measure the amount of liquid that is dispensed from it, right? So it's very important when you get to start using that piece of glassware that you understand how it works. Then we have the pipette. Again, these come in different sizes. Again, these are designed to measure one particular volume. This is a 10 mil pipette. And in order for you to use this, you need something here to suck the liquid up. We have what is called a pipette filler. So basically, you attach it to the top part of the pipette, and then you dip the tip below the surface of the liquid that you're trying to measure the volume of. And then the pipette filler, there are different designs. The one that we have in our lab there's a wheel that you turn, which basically creates a vacuum inside the pipette and allows the liquid to be sucked up into it. And there's a mark that is etched here, which represents the particular volume. So basically, in this particular case, if you want to measure 10 mils of the liquid, you just turn the wheel until the meniscus gets up to the 10 mil mark, and you'd have collected your 10 mils of your liquid. And then this last one, I don't anticipate us using this in our, well, if you're doing Chem 1 and Chem 2, you will be using this particular, actually, wait a minute. In Chem 2, you're going to use it actually. Well, if you're in my lab class. Anyway, so this is a syringe, right? And I'm quite sure you're familiar with how it works. Basically, you stick this into your liquid source and then you pull the plunger here to get the correct number of mils of your liquid, all right? So those are just some examples of glassware that we use in chemistry to measure volume. Okay, here is another example where more than one conversion factors would have to be used to carry out this calculation using volume measurements. It says convert 4.61 times 10 to the 2 microliters to milliliters, right? So again, this is one of those situations where you may not know the direct relationship from microliters to milliliters, but we do know that 10 to the 6 microliters is equal to 1 liters, and 10 to the 3 milliliters is equal to 1 liters. So what we can do is convert from microliters to liters, and then from liters to milliliters. And this is the setup. We multiply the original number by 1 liter over 10 to the 6 microliter, and then we carry on with the next conversion factor where we multiply 1,000 mils over 1 liter, do the number crunching, and you get your answer, which is 0.461 milliliter, right? So that's another example of converting from one unit to another through two conversion factors. Let's see what you can do. Okay, so now we should be able to do, let's see. Okay. All right. What time is it, by the way? Okay, we have enough time. So now we can do number 5 and number 6. Oh no, okay, so let me bring this up on the screen. Okay, talking for this long is making me very hungry. Okay, so this is it right here. Okay, so this question is asking us to convert from 565,900 seconds to days, right? So I'm quite sure we're familiar with the relationship between the different time units, right? We know that 60 seconds, we know that 60 seconds is equal to 1 minute. We also know that 60 minutes is equal to 1 hour. We know that 24 hours is equal to 1 day, all right? So based on what I've just written, you're gonna need 3 conversion factors to go from what the question has given you, which is the 565,900 seconds today. So let's start off with what we're given. We're given 565,900 seconds, right? So the first thing we have to do is convert from seconds to minutes. So that's where this comes in, right? So the way we set it up here is that we're going to put 1 minute above and 60 seconds below. Everybody see that? So therefore the second units will cancel out. So up to this point, you'd have converted from seconds to minutes. Then we multiply by another conversion factor, which represents this relationship. And how do you think we'd set this up? What would go up top here? I'm sorry? 1 hour would go up here, and the 60 minutes will go below. So this minute units will cancel out. Okay, and then now we need to multiply by the conversion factor, which represents the relationship between the day unit and the hour unit. So what would go up top in the numerator? I'm sorry?
1 day.
1 day, and what goes below? 24 hours, exactly. And that's it. The hour units will cancel out. So whatever you get in your answer, the day unit would be associated with that. Where's my calculator? Okay, so it is 565, 900 divided by 60, divided by 60, divided by 24. And according to my calculation, now this I have to round off to 4 sig figs. So according to my calculation, this works out to be I lost it. 565, 900 divided by 60, divided by 60, divided by 24. Okay, so it would be 6.550 days. And that's how that is done. All right? Any questions about this one? Any questions? Any questions? No questions? Okay, let's hear what you have to say about B. Going from years to minutes. So we're going to start off with 17 years, right? What would you multiply that by firstly? I'm sorry?
Years into days.
Okay, years into days. So how many days are in a year?
365.
365 days per year, 1 year, all right? So the year units will cancel out. What would you do next? What would you multiply by next?
Sunday.
Days into hours, okay? So what's the relationship between the day unit and the hour unit? 24 hours in 1 day. So this will cancel out with that. Okay, very good. And then what next?
60 minutes.
60 minutes, 1 hour. And that's it. So let's see here. 17 times 365 times 24 times 60. And I'd have to round this off to 2 sig figs. And the answer I got is 8.9 times 10 to the 6. And the units will be minutes. All right? And that is how that is done. Any questions about that one? Any questions? All right, so based on what we have done, I want to see you on your own, as much as possible, do the others in that question. So for example, and like I said, I don't expect you to memorize all the relationships. So if you want to pull up the tables in on your devices, I would strongly recommend that. All right. So just go to Canvas and pull up. You go to Files and then Tables, and then I think that's it. I don't remember the name of the file that I've saved it under, but you should be able to find it. In the meantime, let me see if I get everybody's attendance, because I know some people joined us online, I think. Oh, only one person. Frazier. Okay, so let me get you down. Yes, ma'am.
Where's the conversion chart on Canvas?
Okay, so let me show you here. If you go to Files and then go to Tables and then go to Tables Chemistry, download that. And this is it. So the page which has the different conversion factors is this page right here, page 7. Let me see here. Okay, so yeah, it's page 7. Okay, somebody's saying something online. Oh, okay. So you guys finished? With number 9? All right. In the time that we have left, I'm just going to complete this chapter right here. So, let's scroll back up. Okay, so basically there are two other measurements we're going to talk about. One is temperature, and the other one is density, which is a bit different from the other types. All right, so let's talk about temperature. What do we mean by this term in chemistry? It is basically a measure of the intensity of heat. And it does not depend on the size of the system. And I'm quite sure this is basically common sense. Heat always flows from a region of higher temperature to a region of lower temperature. All right. And as far as the SI unit of temperature is concerned, it is the Kelvin unit, but there are some other units that are used as well, namely the Celsius and the Fahrenheit unit. And the instrument that is used in the lab to measure temperature is the thermometer. So these are the symbols for the different units of temperature. And I just want to highlight that there's no such thing as degree Kelvin, right? So you don't need that little O as a superscript to include that. All right. Now there's a relationship that exists between the Celsius scale and the Fahrenheit scale, and it is given by this equation right here. Well, this equation right here will give you the relationship between the Fahrenheit scale and the Celsius scale, all right? And of course, you can rearrange it to get the Celsius value if you know what the Fahrenheit is. And the other temperature scale, the Kelvin scale, is very easy to understand. Basically, all you have to do is add 273.15. Well, for our purposes, I'm just going to say 273. You add that to the value in degrees Celsius, and that will give you the appropriate or the correct temperature expressed in Kelvin. And this is basically showing you a side-by-side comparison between the Fahrenheit scale, the Celsius scale, and the Kelvin scale. And this 1.8 here is basically a part of that equation which relates the Fahrenheit to Celsius. Okay, so here's an example. They gave us this question here, and they said that the temperature reaches minus 60 degrees Fahrenheit. What's the temperature in Celsius? So there are two forms of the equation that we know of, but this form is the one that will help us in this case. Basically, all you have to do is put the temperature value here, which is minus 60. And according to this here, that's equivalent to 222 Kelvin. All right, so relatively simple problem if you know what the equation is. And also, this equation is in the table as well. So you don't need to memorize it. Okay, let's see what's next here. Okay, and then the last topic we're going to talk about here is density. Density is actually a combined measurement in that, by definition, density is the ratio of the mass of a substance to the volume. All right? So we can use this formula here to calculate the density. Density is equal to mass over volume. And therefore, as such, the units of density is dependent on what units you're going to use for mass and volume, right? So if the units of density is, the unit of mass is grams and the unit of volume is milliliters, then it's grams per mil. Or you can express it as grams per cm cubed. It's the same thing. Because if you remember, I said that the milliliter unit and the centimeter cube unit are both one and the same. Now, when it comes to gases, we tend to express the density in grams per liter. And the reason why is because for the same mass, gases occupy a larger volume compared to solids and liquids. So we typically express the mass of solids and liquids in grams per mil, but we express the density of gases in grams per liter. All right. And one aspect of density that you need to be aware of is that it is affected by the temperature. Most substances, when heated, will expand, right? So if the volume expands and the mass remains the same, then you'd expect the density to fall. And that's what you see here in this example. The mass, as you heat from 4 degrees to 80 degrees, the volume increases from 1 milliliter to 1.0290 milliliters. And as a result, the density will decrease slightly from 1 gram per mil to 0.97182 gram per mil. And this is just illustrating here the relationship between density and volume. So here we have 3 boxes of the same mass, right? And notice the volume difference, right? Water, 10 mils, sulfur is 4.83 mils, and gold is 0.518 mils. So of these 3, gold would be the most dense of these 3 substances. Or if you look at this side here, these are all 1 gram, cubes, and you'll notice that basically to get the density in each case, you divide the mass by the volume. And again, you'll see that gold is the most dense of these 3 substances. Okay, and this is just giving you some substances and their densities. As I said before, gases tend to be expressed in terms of grams per liter, while liquids and solids tend to be expressed in grams per milliliter. And you can do some calculations involving densities. So for example, in this particular case, in this case, they're asking for the density of a liquid. They gave you the mass, they gave you the volume. Very simple calculation. You take the mass, 12.4 grams, divided by the volume, which is 13.5 mils, and you do your calculation and you end up with your density being equal to 0.919 grams per mil. All right, here's another example. Now this one is used to calculate the density of an irregular shaped object by immersing it in a liquid. So the question says that you have a 35 mil amount of water present in a graduate cylinder, and then somebody adds a piece of copper weighing 98.1 grams to it, and the liquid level rises to 46.0 mils. So the whole idea behind this is the difference between the initial volume reading and the final volume reading, would be the volume of the metal itself, right? So that's why I did this right here, 46.0 mils minus 35.0 mils, that gives you 11.0 mils. That would be the volume of the object. And then to get the density, we just simply divide the 98.1 grams by that volume, and that would give you the density, right? So this picture here is illustrating basically how that is done, right? Start off with 35 mils, then you add your object, the liquid level goes up to 46 mils. That's how we get that difference, and therefore we can calculate the volume. In this particular case, they gave you the density of ether, and they're asking for the mass. So basically, we use the density is equal to mass over volume formula. The question is asking for the mass, so the mass will be equal to the density times the volume. The density is 0.714 grams per mil, multiplied by the volume, which is 25.0 mils, and that gives you the mass in grams. So that's just basically a simple calculation involving density. And that's it, all right? So make sure you complete that assignment. Hold on to this assignment here. In fact, hold on, let me see it. Oh, you should be able to do the rest of this. All right, so I'm going to set up a Dropbox for this one as well. Let me see. Today's what? Today's... I'm going to let it be due on Thursday. All right. So I'm going to set that up later on. So look out for that. And that's pretty much it for today. Unless there are any questions.
Please, number D on number 6.
Uh,
What is the PG stand for?
Oh, pico means 10 to the minus 12. It's in the table. Yeah.
So my Canvas isn't working for any of my summer classes and I called. And they said it's because they dropped me, but they're gonna add me back, but I don't have access to the Canvas.
Do you know, did I give you a time?
They said it should be in by tomorrow.
All right, so did you submit? Oh, yeah, submit the NSR, okay. All right, since that's a problem, then, don't worry about it. When you get your Canvas up and running, then, I'll be able to accept your assignment. All right, so, but it's by what, tomorrow?
Yeah.
Let's do it.
Okay.
I did one.
Yeah.
No, unfortunately. Maybe can I ask one of your friends to make a copy of it? Yeah.
And I wasn't here at the first class, they said that you gave a packet that we have to sign and bring back to you.
Oh, that's the syllabus. I didn't bring that in.
Okay, can I print that online?
Yeah,
Okay, then I'll print it online and bring it.
Yeah.
there you go.
When I get access to my Canvas.
When did this?
Yeah.
I was added in like a day before after this class. And I didn't hear my name called, but I am on,
Yeah. But I finished those,
it's like when you were typing attendance.
a few days ago.
Okay, admittedly, this is a list that I printed
Canvas and everything, the only thing that wasn't called.
on the 13th, so I don't know if,
Yeah.
yeah, I have to check and see online to see. So if you're in the system, that means that it should be there.
My name's.
No, don't worry about it. I remember, no. What's up? Yeah. So you go to the assignments and then I'm not sure what it looks like from the student's point of view, but it should be.
Oh,
good.
the digital training, I thought it was.
I'm sorry. No, what you're gonna do is scan, okay, I think I know what to say. What you're gonna do is scan your assignment. Or you can take a picture of it, if you have a phone, a smartphone. You can take a picture of it and save it as a PDF and submit it that way as well.
Okay, so we have to turn it.
No, no, no,
Okay.
online. Yes, sir.
I came in while you were talking, I don't know if you got my, for attendance.
I would just
What's the last name?
Estrada.
Google metric unit conversion table,
Oh, okay.
and I just put that in my.
Yeah, you too.
Okay. But I don't know. We don't have access to this, I wanna at least do these.
So like.
All right, take care.
I went straight on the files.
And just do it
today.
through PDF.
I went through the files and clicked assignments and chapter one.
Also, sir, I wasn't here last week and there was like we have to type syllabus or something.
Yeah.
Can I do that now?
Well, I don't have the syllabus here, but you can download it from Canvas and sign it and bring it. Next class.
Okay.
Yes.
Did you hear that? Oh, yeah. He said that next week, since we weren't here, download the syllabus on Canvas and just print it out at home and then bring it and sign it. Like sign it and then turn it in.
Oh, yeah. Do you still want me to do that for this class or does it still count from the last?
All right, you made a switch, right?
Yeah, I had.
Yeah, do it for this class, yeah.
Okay. Did you get it?
I didn't get it.
Wait, Ronnie,
It says it was sent.
did Mr. Renfro like give any updates for the situation? Oh, wait. He basically just told me that they were making it a lot harder, so now pretty much the only people that can pass is people who actually work in a lab setting. Like I don't know if you noticed, but the base was heavily geared towards people who already worked in a lab and know all of those things. But for high school students who are completely reliant on the study materials that they give us, and then for the study materials not to match up with the test, it's completely unfair. So he's actually looking at other certification courses to do
Wait,
instead of the
don't.
base,
Is
because
this-
if they're
that's
just
it.
gonna do that
Okay,
and not
thank you.
tell
I got
us
it.
and not
Thank you.
give us the proper materials to work with,
I have
then like what's even the
Yes,
point of
ma'am.
taking it? And some people passed, sure, but
Do you think Dr. Kirk
Mhm.
or Mr. Kirk, he's gonna?
Oh, this is the old list, so I need to print
Discussion over?
a new copy of.
He's like a pure religion teacher. But because I'm locked out of this campus, I can't do anything.
Just. Can you talk to him in person?
I don't even know if he has a phone.
Is it online, like an online class?
No, he has it in person, but I have him at 8 a.m.
You do that too,
Tomorrow.
Because just show up and be like, hey, I have this class, I'm just locked out of this right now.